Question 14. According to the Census Bureau, 13% of American adults aged 18 and over are Hispanic. An opinion poll plans to contact an SRS of 1,200 adults. Part A. What is the mean number of Hispanics in such samples? What is the standard deviation? All right, so let's begin, as we always should, by defining a variable. So let's just use X, and this is going to be the number of Hispanics in an SRS of 1,200. Okay, so the minimum possible value that X could take is 0, and the maximum possible value X could take is 1,200. Okay, neither of those are probably very likely, but still, those are the min and max. Okay, so this variable has a binomial distribution with n equals 1,200, that's the number of trials, and p equals 13%. That's the probability of success, right? In this case, the context is you contact a Hispanic, that's a success. Okay, so now that we've determined that it's binomial, finding the mean and standard deviation are quite simple. We are going to just refer to our formula sheet. Okay. All right, so right here in the middle row, binomial distribution, the mean is just n times p, and the standard deviation is the square root of n times p times 1 minus p. There we go. All right, I was just trying to get that to split screen properly. All right, so the mean of X is n times p, so 1,200 times 0.13, also known as 156. The standard deviation of X is the square root of np1 minus p, so that's the square root of 1,200 times 0.13 times 0.87. And that's 11.65. That was a 6 up there. Okay, so part A is done. Part B. Should we be suspicious if the sample selected for the opinion poll contains 10% or less Hispanic people? Calculate an appropriate probability to support your answer. Okay, so what is 10% of 1,200? That'd be 120. So basically the question is asking, what's the probability that the number of Hispanics is less than 10% or less, so less than or equal to 120. Okay. Right, and then if that probability is low, then that's going to lead to some suspicion, right? It's a statistically significant result. Okay. All right, now technically speaking, the way we should calculate this is we should find the probability of getting no Hispanics in the sample plus the probability of getting exactly one Hispanic, et cetera, all the way to the probability of getting exactly 120 Hispanics. But that's a lot of probabilities to calculate, and then on top of that, we have to add it all up. Okay, so we're going to take a different approach here, which is think about the probability distribution. So our variable is X, number of Hispanics, and then P of x will be the probability. Okay. Remember, we said earlier that the minimum number of Hispanics, although it's not likely, right, there might not be any Hispanics in our sample. Okay. The maximum value is 1,200. Again, not likely, but that's the maximum possible value. Okay. Now we know somewhere in here, right, we could get 120, we could get 121, we could get 122, we could get 119. Okay. Now what we want to do is figure out the probability of getting 120 or less. So can we find basically the sum of all these probabilities? Okay. And we can do it pretty quickly by using the binom CDF function. Okay. So this is a neat little function on the calculator that helps you find the probabilities of at most a certain value. Okay. All right, so number of trials is 1,200. Probability of success, 13%. And our boundary value, we're going to at most 120, because remember, that's 10% of our sample. Okay, let's type this in, 1,200, 13%, 120. All right, the probability is pretty small. It's in scientific notation, but it's 0.0008285. So it's very, very unlikely that we would actually get a sample that contained 10 or less Hispanic people. Okay. So if that were to occur, it's probably not happening by chance because it's so unlikely. It's probably happening for some other reason. So we should be suspicious about maybe the way the opinion poll was conducted. Okay. So to answer the question, should we be suspicious? Yes. The likelihood is so low that this, or let's say the probability is so low. Okay. The probability 0.0008285 is so low that this outcome is unlikely to occur by chance alone. So there's probably some other factor in play that would produce this result. It's not just chance.